All right, let's solve this problem. So we are given the mass of the ball and the initial speed of the ball, and we are told that it does a horseshoe, goes halfway around the rim. So let's draw the situation real quick. That's my golf ball. Its initial velocity is 1.2 meters per second. It goes towards the hole and then does a horseshoe or like a semicircle and comes back and starts traveling towards the golfer again at a velocity of 1.1 meters per second. And then we are told that positive direction is from the golfer to the hole. So that is my positive direction. We are asked to find the impulse. We know that the formula for impulse is the final momentum minus the initial momentum. So let's look at the momentums. So the initial momentum is mass times initial velocity. The mass is 0.045. The initial velocity is positive 1.2. This should give me 0.054 kg meters per second. Now the final momentum is again mv final. So the mass is 0.045 and the velocity is negative because it's in the negative direction, 1.1. And this is equal to negative 0.0495 kg meters per second. So calculating the impulse, its final momentum, which is 0.0495, minus the initial momentum, which is 0.054. Just calculate this real quick. 0.054. So the value is 0.1035 kg meters per second. Looking at the number of significant figures, so there's 2 here, there's 2 here, and there's 2 here. So we should have 2 significant figures in our solution, in our final answer. And that is the impulse. Moving on to the next question. So we are told that the angular velocity of a rotating wheel is shown in this graph. So the angular velocity starts at 4. The angular velocity starts at 4 and it goes all the way to -2. So this means if let's say the wheel started rotating from theta equal to 0, it first had a positive velocity and then it slowly stopped, and then after time 3 point something it started having a velocity in the negative direction. So what we should do is divide the problem from time 0 all the way to time 3 point something, and that will give us the positive angular displacement. And then from this point onwards until time equal to 5 seconds, we'll get a negative displacement. So let's look at yeah, let's do this way. Displacement is the area under the curve because this is velocity. So displacement 1 is equal to half times the height of the triangle, which is 4, and the base of the triangle, which I don't exactly know. So I'll just call this base. And how do I find base? I have to look, because this is a straight line, the velocity went from 4 to -2, which means 4 minus -2 is gives us 6. So the speed, the difference in speed was 6 radians per second. This is delta omega, and the delta t was 5 seconds. So let's calculate the alpha. Alpha is delta omega by delta t, so 6 by 5. This is equal to 1.2 radians per second squared. So to find the velocity, the time when the angular velocity is 0, my delta omega would be 4 minus 0. So I have to find delta t. So again, alpha is equal to delta omega by delta t. This would be 4 by t. This is equal to 1.2, again because it's a straight line. Therefore, t is equal to 4 divided by 1.2, and this is equal to 3.33 seconds, which is this. So my displacement 1 is equal to half times 4 times 3.33. So this is 6.66 or 6.67 radians. Now let's look at the displacement here. So displacement 2 is equal to, again, half times height by base. So the height is 2 radians per second, and the base is 5 minus 3.33, because we know this entire thing is 5, and we just found out the red part. This is 3.33. So this will be 5 minus 3.33. So the answer should be 1.67 radians, but this should be negative because my velocity is negative. So negative. So the total displacement between the total angular displacement between time 0 and 5 seconds is displacement 1 plus displacement 2. Displacement 1 is 6.67. Displacement 2 is negative 1.67. 1.67 minus 6.67. It's 5 radians. Moving on to the next question. All right, so this hamster runs on the wheel for a few seconds, and initially the exercise wheel, let's draw the exercise wheel. All right, let's say this is the hamster. All right. So the radius is given. I'll just call it R, and its mass is m. And initially, this particular hoop has a kinetic energy half I omega square. Its initial omega is equal to 0, so the initial kinetic energy is 0. Now, what about the final kinetic energy? In the final situation, we are told that the hamster is running at a speed of 1.3 meters per second. So if the hamster is running at 1.3 meters per second, this is just going to be so V is equal to R times omega. So the angular speed at this point is going to be V divided by R. And because this is a hoop, its moment of inertia is mr squared. So my final kinetic energy is I times omega final squared. That means half times mr squared times omega final is V divided by R. So let me fix the R real quick. This is V divided by R squared. Quickly solving this, this is m r squared V squared by R squared. R squared get cancelled. So it's half m V squared, which is times 6.5 times V is 1.3 squared. Quickly calculating this, 5 times 6.5 times 1.3 squared. I get 5.49, which turns out to be 5.5 joules. Now, what we know about work done is it is equal to the final kinetic energy minus the initial kinetic energy. So the final kinetic energy is 5.5 joules, initial kinetic energy is 0. So the work done on the wheel by the hamster is 5.5 joules.